Okay, going on to topic 4 now of module 2. We're going to be looking at some strategy as background for factoring trinomials. So I believe I have this in your new books, where first we put it in standard form, and remember sometimes there's an a there where the a is 1. We don't write it, but ax squared plus bx plus c. In these cases, the a will be 1, so that's why we didn't write it. Put it in standard form of the quadratic expression. Now, if there is a common factor, we take out the common factor. So that common factor would be out here. Then we put two sets of parentheses that are going to end up being the binomials that when you FOIL them would give you this, and we're going to undo the FOIL and then check by the FOIL. So here's what we have then. Let's move it up. Now there is a protocol, and you're practicing it helps you to improve your skill here. So is this in standard form? Yes. Is there any common factor? No. So the next thing we do is put two sets of parentheses right underneath it. Now we're undoing the FOIL. And we did these two to get x squared. So what do you think would go here? Well, the x and the x. There's no other choice. Now, we're going to go in a different order. We're going to look at the last term, which is a 15, when we multiplied this and this to get a 15. But then we had to do our outers and our inners. So basically, it's a combination of factors that when we add them up, we get an 8, but when we multiply them, we get a 15. So mentally you can start going through the factors. 1 times 15, 3 times 5, and there you have it. So this will be a 3, and this will be a 5. Now check your signs. Here it's positive, here it's positive. So all these will be positive. And when we do the FOIL, it checks out. All right, here now, notice our middle sign is negative. It's in standard form. There are no common factors, so two sets of parentheses. And right underneath them is a good way to do it. So to get our first term, it's y and y. Now here we want factors of 4 that add up to 5. Well, the only ones who would do that is a 1 and a 4. But notice our middle sign is negative. So what will these signs be in order to get, when we do our outers and inners, a negative 5? But they both have to be negative. And then when we FOIL it to get our last term, it does give us a positive 4. So here's a way where you have a little skill, artistic skill, figuring out what could it have been, and then you check it by FOIL to see if you have the right answer. Now here's a case where, is there a common factor? Yes, there's a common x. So we factor out the x. This is sort of an intermediate step. Now we want to factor this. So we put two sets of parentheses, x and an x. Now interestingly, this is a negative 40. So one of these has to be positive and one of these has to be negative. And when we add up these factors, it adds up to a negative 3. So factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. Now if we look at 5 and 8 here, the difference of 5 and 8 is 3. And if we want a negative in the middle term, if we have a negative 8 there and a positive 5 there, when we FOIL this, we see we get this. So this is our factorization. It's in standard form. Factor out the greatest common factor, 2 sets of parentheses, and you're trying different combinations until you get something. You check the signs, do the FOIL, and you see you have the right answer. So continuing our protocol here, is it in standard form? No, this is not in standard form. So first step, put it in standard form. Any common factors? No. Then write 2 sets of parentheses. And we know these are easy because it's just usually an M and an M there. Factors of 20 that have a difference of 1. Well, a 5 and a 4. And in order to get a positive 1 in the center, the 5 would need to be positive. The 4 would need to be negative. So again, when you FOIL, it checks out. Now, here, is this in standard form? Yes. No common factors, 2 sets of parentheses, an X and an X. Now, there's not a lot of different factors of 10. There's 1 and 10 and 2 and 5. So you might try it, 2 and 5, because you want a difference of 3. But you want to have a negative 3 in the center. In order to do that, this would have to be a negative 5, and this would have to be a positive 2. That would give us a negative 3x in the center. But when we did our last term, we would get a negative 10 there. So in this case, there are no factors. So we say this is prime. And if we saw the work, if this were something you had on your exit exam, you tried it, but realized it doesn't factor, it's prime. Now every once in a while we'll see something like this, where there are 2 sets of letters. It's in standard form. There are no common factors. And we could put an A there and an A there. And we have a B there. We could put that there as well. Okay, so now we just need to figure out factors of 28 that have, in this case, a difference of 3. And it looks like it will be 4 times 7. 4 times 7 is 28. But when we add, one of them has to be negative, one's positive. Our middle term is negative, so the larger one here is negative and positive. Now, if for some reason you reverse the signs, when you did the FOIL, you realize you have the signs in the wrong place, and you just switch them before you put them in MATLAB, because you're going to FOIL this to check. Okay. Now up here, all of these were just expressions. We're now putting these into the form of equations here. So let's see the protocol. Now this is in the standard form, ax squared plus bx plus c equals 0 of the quadratic equation. Now to solve them, it must be in this form. and this one is in this form, where our a term is just a 1, so there's nothing there. So the strategy is finding the zeros. We're going to factor this. And some of these aren't too bad to factor. X, 5, 2, adds up to 7. They're just all going to be plus. Now what's the next step if you need to show the work? We'll take each of these factors. Remember, it's AB equals 0, the principle of the zero product. This will be x plus 2 equals 0, or x plus 5 equals 0. So here x equals a negative 2, or x equals a negative 5. And there's what we have. Works out very well. Now you might think in letter B we just take x minus 5 equals 20 and x plus 5 equals 20. But that would be absolutely wrong. In order to do this one, we have to first put it in standard form, that is, have the left side equals 0. So we can't do that. So the first thing we have to do is get this in standard form. So we FOIL this, x squared minus 2x minus 15 equals 20. I'm just foiling. And I did this part in my head. I think it looks good. Now I put it in standard form. X squared minus 2x. Now I'm going to bring this 20 over to this side. As a negative 20, this becomes a negative 35 equals 0. Now we have it in standard form. So we factor this, and we get x, 7, 5. We want a negative in the center, so our 7 has to be the negative. This is plus. I FOIL it, and it checks out. So x plus 5 equals 0, or x minus 7 equals 0. So here x equals a negative 5, or x equals 7. Now it's critical that you have your signs correct. Now let me mention one of the things we're going to be doing later. We're going to have the answers that x equals negative 5, x equals 7, and they'll want us to say, what was the original equation? So what we do is we work backwards. We then say, well, it was x plus 5 equals 0, x minus 7 equals 0, and then we work backwards, put these in factored form, FOIL these, and there's our equation. Now we wouldn't be able to get this one, but this one and this one are equivalent. Okay, let's take a look at example C. Well, the first thing we have to do is put it in standard form. So I'm transposing this. Now, is there a common factor? Yes, I can take an x squared out of everything. And I get x squared plus 10x minus 24. Now I factor this. X, factors of 24 that have a difference of 10. Well, how about a 12 and a 2? Again, I had to think about that a little bit. Now, which one needs to be positive? Well, the middle term is positive, so this is positive, and this will then be negative. So I factored that. Now I get x squared equals 0, or x minus 2 equals 0, or x plus 12 equals 0. So here we're going to have two answers that are 0. That would be one answer. We'd only have to write it once. And then here, this is going to be x equals 2. And here, x equals negative 12. Okay, so this is an equation to the fourth degree up here. Theoretically, we need 4 answers. 2 of them are going to be the same, so we'd only write it once. And this is the work to support letter C. Now, when you get big numbers like this, factoring could be a challenge, and is a challenge. What would it be like if we did it using that math program? Well, as you can imagine, the numbers are pretty big, and these are what x would be when we find the zeros. Well, I can also ask this program to solve it by factoring. Now I've put that in. I don't want it to graph, I want it factored. So I click on answer. And then it goes, it says, puts it in standard form, goes through it, and there are the factors right there. Wow. And notice here, once we equate it to 0 in finding the zeros, because I didn't put equals 0 here, I just used the expression, then you would equate this to 0, so this x would be a positive 67, and this would be a negative 55. And if you recall, when we had our graph, it went through at a negative 55, and it went up this end on a 67. So, again, I don't expect that you'll have one like this, because you're not required to have it, but it was here, and we did it. Now, in this case, as we mentioned before, they're giving us the answers. So we're saying that x equals a negative 4, x equals a positive 1, x equals a 3. Now, from this, we want to reverse the process. Well, here, this in parentheses would be x plus 4, because if we equals 0, we put the negative 4, x equals negative 4, so we're transposing that back, and this one will be x equals a negative 1, and here x will equal a negative 3. So these were our answers. All of these were in a sense equal to 0. So this was transposed to get a negative 4. This was transposed to get a 1. This was transposed to get a 3. So how do we do this? Well, we're going to FOIL this, and we're going to get, and all of this, of course, equals 0 at the end. So this is going to be x squared is a plus 4x minus 1 is a plus 3x minus 4. So when we do the FOIL of this, we get that, but we now have to multiply it by this, which we did earlier in a similar one. This times this. Let's let you work on it. So we're using that skill of multiplication, checking the signs out carefully. Notice these will cancel out to get a 0 here, which we don't write, and we need to put it in function notation. Okay, that'll wrap up this section, and we'll go on to 2.5.